Our task for this problem will be to determine the two networks obtained by replacing A, the primary and the ideal transformer with an equivalent circuit, and B, the ideal transformer in the secondary with an equivalent circuit. The ideal transformer relationship equations for voltage and current with respect to the turns ratio are given by these two equations. The negative sign in the first equation takes into consideration the spot markings on the transformer. The primary spot is the reverse of the secondary spot, so the voltages across the transformer will be reversed. The equation for reflecting impedance from the primary of the transformer to the secondary is, and then plugging in the actual turns ratio gives us ZS is equal to 4 times the primary impedance ZP. These are the necessary equations for developing the equivalent circuits. A. Replacing the primary and the ideal transformer with an equivalent circuit. In other words, we are going to move the components of the primary side of the transformer to the secondary side, starting with the impedance or the 1 ohm resistor. Using the equation for impedance transfer, we know that ZS is equal to 4ZP. Since ZP is 1 ohm, ZS is equal to 4 times 1 or 4 ohms, and the equivalent circuit will look like this. This circuit will react the same as the original circuit. However, we want to transfer all of the components of the primary side to the secondary side for the equivalent circuit. In the circuit, we have now V1 equal to 1 at 0 degrees. So you can use the voltage relationship equation, which can be written as this. Substituting actual values, V2 is equal to 2 at 180 degrees. This transfers the power supply on the primary side of the ideal transformer to the secondary side. Yes, the circuit itself may be considered an equivalent circuit, replacing the primary side of the transformer. However, the ideal transformer adds nothing to the circuit, so we can just remove it. Moving on to B, replacing the primary and ideal transformer with an equivalent circuit. In other words, we are going to move the components of the secondary side of the transformer to the primary side, starting with the impedance or the 3 ohm resistor. Using the equation for impedance transfer, we know that ZS is equal to 4ZP, which can be rewritten as ZP is equal to ZS divided by 4. Substituting our actual values, we get ZP is equal to 3/4 ohms. We can now move the impedance of the primary side by changing its value to 3/4 ohm. We still have a voltage supply left on the secondary side of the transformer. So once again, you can use our voltage relationship, which can be rewritten to look like this. V1 is equal to minus V2 divided by 2. Substituting actual values, again, we get V1 is equal to minus 1 at 0 degrees. We can now move the secondary power supply to the primary side. Our equation tells us that we must reverse the polarity, hence the reason for the negative sign. So our circuit will now look like this. Once again, the ideal transformer becomes superfluous, so we can just remove it. And our equation, our equivalent circuit, will now look like this. And we're done. In recent years, the reality of climate change has become impossible to ignore. Severe weather events are growing more frequent and more intense. For homeowners, this means that utility power outages are no longer inconveniences. They can last for hours, days, or in extreme cases, even longer. The question is no longer if, but when. You'll need a solution to keep your homes powered and your family safe. Now is the time to prepare and ensure you're not left in the dark when the next storm hits. Here are some trusted resources to help you prevent power outages at home. Jackery Canada at this web address. Bluetti Canada at this web address. Bluetti USA at this web address. And Bluetti Australia at this web address. And finally, EcoFlow may be found at this web address. And for those of you in Australia, here is an added bonus. Bluetti has just come out with their newest fleet edition, the Apex 300. It can put out 3,840 watts for 2,764 watt hours. It has 120 volt to 40 volt dual voltage output and is expandable up to 58 kilowatt hours at 11.52 kilowatts. With the Bluetti app, you will receive real-time weather alerts. This unit charges at 30 kilowatt solar or 11.52 kilowatts with an auxiliary generator. It powers HVACs, electric vehicles, and heavy-duty loads, and it pays for itself in as little as 2 years. In order to get more information and take advantage of this special offer, simply go to this web address. You can also obtain an exclusive offer or a 10% discount by using this code, 𝐃𝐈𝐒𝐂𝐋𝐀𝐈𝐌𝐄𝐑. And not to be forgotten, for those of you in Canada, here is an added bonus. In order to get up to 50% savings on some of Jackery's products, simply go to this web address. In addition to any price reduction at this time, you can realize an extra 5% discount by using the above email address in combination with this code, DEAL5. And finally, I want to make you aware of the fact that EcoFlow's brand new Rapid Pro power bank will officially be launched on August the 25th. The EcoFlow Rapid Magnetic Power Bank is designed for individuals needing portable charging solutions. This power bank features two models, a 5,000 milliamp hour version and a more robust 10,000 milliamp hour version, catering to different charging needs. You can take advantage of huge early bird discounts and find out all of the details about these rapid magnetic power banks by going to the following web addresses. In Canada, go to the web address, and in the US, go to this web address. Furthermore, you can get an exclusive 5% further discount by using the code 25EFRAFF5. Ready to go beyond just solving problems? If you've been following my daily post and enjoying the sample problems, you're going to love this. All of these problem sets and more are now available, or soon will be, on my official course site. My stands for electrical training. Just go to the web address that you see at the bottom of this slide, https://stand.store/GVB.